Welcome to the Galvanic Applied Sciences tutorial series. In this video we will show how to check Analysis, Status, and Alarms tabs. Start the 903 Analyzer software. The Analysis window is the default main screen of the 903 GUI. The Analysis window allows the user to see the status of many features of the analyzer all at a glance. Log on to access data. Read-only mode. You can read but not write to the analyzer. Update mode. You are free to change any configuration parameters and write them to the analyzer. The default password is 2222. In this example, the analyzer is set up for 4 streams. The GUI automatically polls the analyzer every 2 seconds, causing this page to be updated continuously. This allows the user to be able to monitor the status of the 903 analyzer live. On the left-hand side of the Analysis tab window is a column of 19 fields. The analyzer date and time shows a correct date and time on the analyzer. It is important that this be set correctly so archive data has a correct timestamp. If this is not correct, ensure the PC time and date is correct and then press the Synchronize Time button. Site ID is the 903 serial number. Site shows the site name the 903 is installed at. Location shows the specific location within the site the 903 is installed at. Analysis state shows the current state of the 903. Current analysis shows the current run type being performed by the 903. Analysis time shows the number of seconds elapsed since the beginning of the current analysis cycle. Run number shows the current number of runs in the current analysis type as well as the total number of runs of this type to be performed. Trended reading shows a trended concentration reading that takes the values of several past concentration readings of the same run type into account. PAA shows the live predictive alarm analysis. Raw millivolts shows the current raw photodiode detector output in millivolts. This reading starts at around 1000 millivolts at start of an analysis and drops as the analysis proceeds. DVDT shows the rate of change in sensor output. Millivolts shows the absolute value of the sensor output increasing from 0 at the beginning of an analysis. Zero offset shows the value subtracted from all concentration readings. This value is the parameter that must be subtracted from a reading taken on gas containing no hydrogen sulfide in order to make the 903 read approximately 0.00 ppm. A calibration gain shows the value that the sensor output is multiplied by in order to produce a valid concentration reading. Sensor LED current shows the current used to ensure a reading of 1000 millivolts is obtained by the sensor block on pure white tape. Sensor temperature shows the current ambient temperature at the sensor block in degrees Celsius. Tape remaining shows the length of tape in feet remaining in the reel. Run counter shows the current number of runs of all types carried out by the 903 since it was first started up. Sequencer state shows if the sequencer is currently in an automatic or manual state. This tab screen could be up to 4 stream sections, giving the operator the last or current results on any stream activity. The field that is highlighted in yellow is the next operation to be executed in the queue. The blue highlighted field is an operation currently in progress. The H2S field either shows the current analysis reading if highlighted blue or the last reading when that stream is run. Total sulfur field shows either the current analysis reading if highlighted blue or the last reading when that stream is run. Reference 1 and 2. A reference gas is used as a periodic calibration check and cannot change the gain. The zero run is a way to check what the analyzer will read on a gas that contains no H2S. Running this run will result in a zero offset being calculated for the analyzer. Calibration is used to automatically calibrate the analyzer and calculate a new gain factor. Next is the Status tab. It gives the operator the current status of the analog outputs, relays, solenoids, analog inputs, discrete inputs, and what voltage input source is in use. In some cases, the activation or deactivation of the status indicators may suggest there is an alarm associated with it. For instance, the discrete input 1 may be used as a temperature switch for the total sulfur option. If the associated indicator is illuminated, it means the TS oven has not yet reached its optimal temperature yet and will show up on the alarm list when viewed on the analyzer display. The box labeled analog outputs shows the current output from 4 to 20 milliamps of the two analog outputs on the 903 electronics board. Analog outputs can only be configured from the GUI, not from the keypad. The box labeled relays shows the current status of the 4 relays. The circle beside each of the relay titles indicates the status. A red color means the relay has been triggered, while a gray color means the relay has not been triggered. The box labeled solenoid shows the current status of the solenoid drivers on the 903 electronics board. If the analyzer is not configured with any solenoids, this box can be ignored. A gray circle beside a solenoid label indicates the solenoid is de-energized, while a red circle indicates the solenoid is energized. The box labeled analog inputs displays analog input values in engineering units as configured under the analog inputs page. The box labeled discrete inputs shows the current status of the discrete inputs on the 903 electronics board. These discrete inputs can be such things as low pressure switches, oven temperature sensors, or piezo buttons used to initiate specific runs. A red circle beside a discrete input indicates that the particular discrete input has been triggered, while a green circle indicates the particular discrete input has not been triggered. Discrete inputs, wet contacts, are similarly configured. The third tab is the Alarms tab. This tab allows the user to view the status of most of the enabled analyzer alarms. The Alarms tab is divided into 3 sections. The top left side has 13 alarm references, and their associated indicators are referred to as global alarms. Global alarms are non-analysis related alarm parameters that affect all streams identically. These alarms are related to hardware and other physical parameters that affect the operation of the analyzer. In many cases, the set point for these global alarms is user configurable. Each alarm can be configured to be active or not active and to trigger certain outputs, either solenoids or relays. The high temperature alarm will be triggered if the temperature experienced by the sensor block's onboard temperature sensor exceeds the set point value in degrees Celsius. The low temperature alarm will be triggered if the temperature experienced by the sensor block's onboard temperature sensor goes below the set point value in degrees Celsius. Sensor LED current. If the sensor current rises above the set point value, the alarm is triggered as there is likely a problem with the sensor block. The set point for this alarm is configured at the factory and should not be changed. Sensor COM alarm is an alarm that triggers if the unit is no longer able to communicate between the motherboard and the sensor block. If this is triggered, the unit will no longer function correctly. The RTC battery will be triggered if the voltage from the onboard clock battery, which maintains the analyzer's real-time clock should the power fail, drops below a hard-coded value. Maximum tape advance will be triggered if the motor advances the tape more than a certain number of rotations without getting a corresponding signal from the pulse counter that controls the tape advance. If this alarm triggers, it will generally indicate a problem with the encoder. The length of the maximum tape advance can be set by the user, but is advised to leave it set at the factory default. The 903 can be configured with an optional optical low tape sensor. If this alarm is triggered, it means the tape is very low and should be replaced. The low tape alarm, should it be installed, is triggered when there is approximately 15 feet of tape remaining. Tape length. A low tape alarm can also be triggered based on the amount of tape that is calculated to be remaining by the pulse counter. The alarm will trigger when the length of tape calculated to be remaining in feet drops below the number set in this field. For this alarm to work correctly, it is essential the length of tape in the reel be reset to the correct length value in the global screen whenever a tape is replaced. Tape movement. If the pulse counter no longer receives any pulse when the tape is advanced by the motor, this alarm is triggered. Tape movement and maximum tape advance can be triggered by the same problem, so both should be analyzed. Possible causes of this alarm include tape breakage, jamming of the encoder, and motor failure. Sensor calibration. If the 903 is unable to adjust the detector output to 1000 mV on white tape, even after raising the sensor current to the maximum allowable value, the sensor calibration alarm will be triggered. This alarm will typically be triggered if the tape does not move correctly and the stain becomes exceptionally dark before the next analysis begins, or if there is no tape present. Bypass mode is a mode of the analyzer that disables any outputs that may be triggered by alarms. This mode is useful when doing any kind of service work that may result in triggering of alarms. For normal operation, it is essential that bypass mode be disabled. When bypass timeout is enabled by putting a check mark in the enable box, bypass mode will automatically be exited by the analyzer after a certain number of seconds after the last keypad button push. The length of bypass timeout in seconds can be set in the bypass timeout field. By default, this is set to 450 seconds and disabled. When the 903 is in bypass mode, the output from both analog outputs goes to the failsafe output to ensure the user recognizes the analyzer is in bypass mode. DC power alarm tells you DC power is present, while AC power alarm tells you AC power is present. The top right side of the Alarms tab are 8 analog input alarm references and their associated indicators. The 4 analog input greater than limit and 4 less than limit fields refer to alarm set points set on the analog inputs tab. The analysis alarms for each of the 4 streams have 6 available types of gas runs. High alarm is the first warning set point in a concentration range where the operator may need to be alerted of a situation in progress. High alarm is the second warning set point in the concentration range where the operator may need to take actions to alleviate this alarm. Many users will use the set point to shut in the process being monitored. Deviation alarm is an alarm when consequent runs vary from each other by a greater percentage than the value set on the Streams tab. This alarm is disabled for the H2S run as it is of little value for H2S runs. It is expected some degree of variation in H2S concentration from analysis to analysis will occur. Lock alarm. This alarm will lock the analyzer in whatever stream it is currently in if it exceeds limit value. All alarm types can be configured to trigger specific relays and/or outputs. To enable specific outputs for each alarm, go to Streams and simply put a check mark in the desired checkboxes in the Actions box. This concludes the How to Check Analysis Status and Alarms tabs tutorial.